Hello student of class 9, let's continue our chapter Force and Laws of Motion. And today we are going to discuss Newton's third law of motion, which is a qualitative law, means we cannot express this mathematically. So logically we can understand this law. The first two laws of motion tell us how an applied force changes the motion and provide us with a method of determining the force. And in third law of motion, it is said that when an object exerts a force on another object, the second object instantaneously exerts a force back on the first. These two forces are always equal in magnitude but opposite in direction. These forces act on different objects and never on the same object. For example, in the game of football, sometimes while looking at the football and trying to kick it with greater force, collide with a player of the opposite team, both feel hurt because each applies force to the other. In other words, this force is a pair, not just for one force. And the two opposite forces are always known as action and reaction forces. So student, it is a very important law. In this law, we come to know that every action has equal and opposite reaction. Let us consider two spring balances connected together as shown in figure 9.10. The fixed end of balance B is attached to with a rigid support like a wall. When a force is applied through a free end of spring balance A, it is observed that both the spring balance show the same reading on their scales. It means that the force exerted by spring balance A on balance B is equal but opposite to the direction to the force exerted by the balance B on balance A. The force which balance A exerts on balance B is called action force, and the force which exert B on A, that is called reaction force. This action and reaction force always equal in magnitude, but direction is always opposite. So you can see several examples in your daily life. When a truck collides with another truck, then both the truck will go apart because both the truck apply force on each other, and that force is equal force. But remember, this force exerting by one object to another object, and so we can say it is the opposite force. So we can say, according to Newton's third law, it is said that every two objects in this universe exerting force each other, and that force is equal but opposite in direction. So action and reaction is always equal force but opposite direction. Suppose you are standing at rest and intend to start walking on road. You must accelerate, and this requires a force in accordance with the second law of motion. Which is the force? Which is this force? Is it the muscular effort you exert on the road? Is it in the direction we intend to move? No. You push the root below backward. The root exerts an equal and opposite reaction force on your feet to make you move forward. So here also Newton's third law apply when you walk on a route, because when you walk, you push on the ground by your feet, and the ground also give you a force in opposite direction so that you move forward. It is important to note that even though the action and reaction forces are always equal in magnitude, these forces may not produce acceleration of equal magnitude. This is because each force acts on a different object that may have a different masses. So remember, this force, action and reaction are equal, but depending on the mass, that force may be small also individually, but the action and reaction force is always equal. You can see one example is there, you can clear here. So in this gun, bullet is also there. So this bullet mass is very small and the gun mass is very high. So in this case, both will exert each other equal force. Though mass of the gun is very high, so the exerting force by the gun will be more. So when a gun is fired, it exerts a forward force on the bullet. The bullet exerts an equal and opposite reaction force on the gun. This results in the recoil of the gun. Recoil means going back by getting a force. Since the gun has a much greater mass than the bullet, so the acceleration of the gun is much less compared to the acceleration of the bullet. So the third law of motion can also be illustrated when a sailor jumps out a rowing boat. As the sailor jumps forward, the force on the boat moves it backward.